Logarithmic Functions by Matt, Jess, and Jared.
Every function with the form f of x equals a to the x, a is greater than 0, a does not equal 1, passes the horizontal line test and therefore must have an inverse function.
Definition of a logarithmic function: y equals log subscript a of x if and only if x is equal to a to the y.
The following equations are equivalent. Y equals log subscript a to the x and x equals a to the y. Y equals log subscript a to the x is written in logarithmic form, while x equals a to the y is written in exponential form.
Examples of evaluating logarithms. Directions: evaluate each logarithmic function for the indicated value of x without a calculator. F of x equals log 4 to the 4 base x, where x is equal to 64. The solution to this is f of 64 equals log subscript 4 base 64 is equal to 3, because 4 to the third equals 64.
Number 2. F of x equals log subscript 10 x. X is 1 over 1000. The solution: first you plug the 1/1000 in all the x's. F of 1 over 1000 equals log subscript 10 of the 1/1000th equals negative 3. This is because 10 to the negative third equals 1 over 10 to the third equals 1 over 1000.
Properties of logarithms. Log subscript a base 1 equals 0 because a to the 0 equals 1. Log subscript a to the a equals 1 because a to the 1 equals a. If log subscript a to base x equals log subscript a base y, then x equals y. 1-to-1 property. Log subscript a base a to the x and a to the log a to the base x equals x. That is the inverse property.
Examples of using the properties of logarithms. Directions: solve using properties of logarithms. A. Solve for x. Log subscript 4 x equals log subscript 4 equals 8. Solution: use the 1-to-1 property through this property and x will equal 8.
B. Solve for x. Log subscript 5 to the 5 equals x. Solution: using this property, log subscript a base a equals 1 because a to the 1 equals a. The answer would be x equals 1.
C. Simplifying log subscript 5 to the x. Solution: to use this property, if log subscript a to the x equals log subscript a base y, then x equals y. The answer is log base subscript 5 base 5 to the x equals x.
D. Simplify 7 to the log subscript 7 14 base 14. The solution to this is using this property. If log subscript a base x equals log subscript a base y, then x equals y. The answer is 7 to the log subscript 7 to base 14 equals 14.
The natural logarithmic function. For x is greater than 0, y equals the natural log of x, if and only if x equals e to the y. The function given by f of x equals log subscript e base x equals the natural log of x, is called the natural logarithmic function. Properties of natural logs. The natural log of 1 equals 0 because e to the 0 equals 1. Natural log of e equals 1 because e to the first equals e. The natural log of e to the x equals x because when you raise e to the ln, they cancel out and you get x. That is the inverse property. If the natural log of x equals the natural log of y, then x equals y. That is the one-to-one property.
Examples of using properties of natural logs. Directions. Use the properties of natural logs to rewrite each expression. A. ln 1 over e, and the solution to this is, using the inverse property, the natural log of 1 over e is equal to the natural log of e to the negative 1, which is equal to negative 1. B. E to the natural log of 5, and the solution to this is, using the inverse property, e to the natural log of 5 is equal to 5.
C. The natural log of e to the 0. The solution, using this property, the natural log of 1 equals 0 because e to the 0 equals 1. Therefore, ln e to the 0 equals ln to the 1, which equals 0. D. 2 natural log of e. The solution, using this property again, is the natural log of e equals 1 because e to the 1 equals e. Therefore, 2 to the natural log of e equals 2 times 1, and that equals 2.
Properties of logarithms. The change of base formula. Let a, b, and x be positive numbers where a does not equal 1 and b does not equal 1. Base b. Log subscript a base x is equal to log subscript b base x divided by log subscript b base a. Base 10. Log subscript a base x is equal to log subscript 10 base x divided by log subscript 10 base a. Base e. Log subscript a base x is equal to the natural log of x divided by the natural log of a.
Changing base using common logarithms. A. Log subscript 7 base 15 equals log subscript 10 base 15 over log subscript 10 base 7. The solution of this is log subscript a base x equals log subscript 10 base x divided by log subscript 10 a leads to about 1.76091 over 0.85098. The answer is about 1.39166.
Changing bases using natural logs. A. Log subscript 6 base 37 is equal to the natural log of 37 divided by the natural log of 6. The solution to this is log subscript a base x is equal to the natural log of x divided by the natural log of a leads to approximately 3.61092 divided by 1.791759.
Expansions properties of log and natural logs. Where a is greater than 0, a does not equal 1, n equals all real numbers, u is greater than 0, and v is greater than 0. Log subscript a base uv can also be written as log subscript a base u plus log subscript a base v. Or in the natural log of subscript a base uv can also be written as natural log of u plus the natural log of v. Log subscript a base u divided by v can also be written as log subscript a base u subtracted by log subscript a base v. And the natural log of subscript a base u divided by v can also be written as the natural log of u minus the natural log of v. The log of subscript a base u to the n can also be written as n times the amount of log subscript a base u, or natural log of u to the n can also be written as n times the natural log of u.
Examples of expanding logs. A. Log subscript 4 base 7 times x to the 9th times y. The solution to this is log subscript 4 base 7 plus 9 log subscript 4 base x plus log subscript 4 base y.
B. The natural log of the square root of 4x subtracted by 5 divided by 16. The solution is half of the natural log of 4x minus 5 minus the natural log of 16.
Examples of condensing logs. A. 1/2 log base x plus 7 log base x plus 2. The solution to this is log square root of x times x plus 2 to the 7th.
B. 3 times the natural log of x plus 4 subtracted by the natural log of x. Since it's a subtraction, you can turn it into a division, so the natural log of x plus 4 to the 3rd divided by x is the same as letter B.
1/2 times the quantity of log subscript 3 base x plus log subscript 3 base x minus 3 is the same as log subscript 3 base the square root of x times x minus 3. Bang!
Bang!